Correct. Actually, I need to dip the display in that way. Let's see here. Thank you, Warren, and also thanks to Robin for bringing me here, and very honored to be following Jesse, and definitely took a lot of good notes. Maybe I think in the context of maybe boxing, I will maybe contrast our fighting style towards the end of this. In any case, I'll just jump in right now. This is actually, I'm just going to tell you kind of a story of kind of how we got to doing what we're currently doing. And it kind of starts over here in this building that's pictured here. And this is Stanford University's Center for Computer Research in Music and Acoustics at CCRMA, and it's pronounced Karma. This is one of the two places where I work. The other is SMU. And this is kind of a nexus of computer music research where computer science, music, electrical engineering, psychology kind of all come together. And it's really kind of working on things here and other places in the computer music research community that really led to some of the things we are looking at today. But backing up, a couple of decades, this is Game 360, and computers actually have been fairly, always attractive as long as there's been the notion of computing music and sound, due to the precision, programmability, and I think that their potential for fantastical automations. And certainly the IBM 360, this machine is, I think, older than I am, is something that people have used for actually making sound. But I think of this less as a computer, but more as, as a kitchen, where we can actually take raw ingredients and actually build up a dish with a sound in exactly the way that you want. So in grad school, I worked on a programming language called Chuck, which is a sound synthesis language that we use to make music. And I'm just going to actually give you a quick demo of this right now, or attempt to. So this is some Chuck code. If you don't know what this means, do not worry. What I'm going to do here is that Chuck is actually less about kind of what you can program, more about how you can program it. It's about the psychology, perhaps, of actually writing audio programs. So what we have here is actually a program that takes a sine wave, has a set of pitches we're going to choose from, randomly draws from a bag of different pitches, and plays them every so often. And at the onset, it sounds something like this. And that's because we only have one pitch here. What I'm going to start doing here is to actually, on the fly, change this program, and then start exploring what this music can be like. So I'm going to add a major second here, and every time you see an equal sign, I'm actually replacing the previous version of the code with a new version. Add a major third. Let's go ahead and add a perfect fifth. Let's make this a little faster. And that sounds kind of nice, but I bet it sounds even better with some reverb. So add reverb here. Shift this up by a couple of registers. Add a major sixth, major seventh. Make this even faster. Drop this to minor, for example. And here's a way of actually rapidly prototyping sound and music, one line of code at a time. And we're actually thinking the programming language less as a tool, but more as a user interface. And this is the kind of stuff I was working on, but I think the theme that I think I've been trying to really work with is one that straddles between technology, people, and psychology. And it's really, I call it sometimes the aesthetics of design, or some refer to it as computational aesthetics, perhaps in another context. Something else that's another raw ingredient, and I'm going to talk about is the laptop orchestra. The picture here is the Princeton Laptop Orchestra, or PLORC. This is started by music professor Dan Truman and my advisor at Princeton, Perry Cook. And this is actually making a large ensemble of laptops, people, and special hemispherical speaker arrays. These are actually speaker arrays we built at the Stanford Laptop Orchestra, SLORC. We've actually built these out of IKEA salad bowls. And the idea here is that we want to want to use computers to make instruments, but use these to make them sound more like traditional acoustic instruments. So the idea is that you play like a violin, the sound doesn't go through a PA system and comes out round it comes from the artifact. These are meant to give each laptop its own kind of sonic sphere. And certainly, at Stanford, sort of a lot of laptops, and when you put people, laptops, and these speakers together, you have the beginnings of an ensemble. And we use a lot of different interfaces, and we create music and instruments and performances kind of from the ground up. And so let's give you a quick demo here if I can. So this is just a kind of a gaming joystick, something you might get. I think that is like $20 at like something like CompUSA. And you can see this. But basically, when I squeeze the trigger here, this is actually going to a Chuck program that's generating. Wow, it's much clearer. Thank you. It sings synthesis sound. Now that's not a full anyone. It's not a real person singing. But it's also not a recorded sound. It's the computer actually generating this from scratch. And it sounds very synthetic. But then using various parts of this joystick, we make it more expressive by being able to control it expressively. So by tilting it to different parts, we actually hear it sing different vowels. And we'll do so smoothly. It's kind of like gently grabbing someone by the throat and shaking it. If you turn this, get a little bit of vibrato. It's a computer model, so what you can do then is to make, instead of sing, make it breathe. And then I'm going to turn it back to singing mode, and I'm going to actually pair it with the laptop keyboard to actually make another instrument. So I just press the keys Z, C, B, A, D, G, W, E. It's kind of like you can sing kind of low or pretty high. It sounds kind of crazy, and you can play little ditties with this. So let's see. For example. So that's just one of like hundreds of instruments we've created just using commodity computers and just parts that we can find in the world around us. A lot of them are gaming devices. And the more we work with this, the more we kind of find a lot of resonance with this what Ben Schneiderman, an HCI researcher, says that the old computing is about what computers can do, whereas the new computing is about what people can do. And I think this is really the shift that we are continuing to experience between focus on technology only to focusing on technology informed by psychology. And it's with all these ingredients that and also I think a bout of insanity, that I co-founded Smule with Jeff Smith and others in the summer of 2008. Here's to explore music making for people on the iPhone and other mobile devices. So my first app, actually, ironically, is actually not a musical instrument, but a sound-related one. And I'll demo that for you here. It's actually called Sonic Lighter. And, let's see, just here, I'm just going to turn on the Sonic Lighter.